Hey there, I hope you're doing well and thanks for coming to my channel. So in this video, we are going to talk about quicksort algorithm. So before starting the implementation part or the dry run, I want to mention that quicksort algorithm follows divide and conquer method. So what is this? So it is nothing but suppose if you want to uh, attack your opponent. So at first you will divide your opponent in single part, and then you will conquer the output as the way you want. So that's in a layman term, that's divide and conquer. So this, when we will implement this quicksort algorithm, it will follow a recursive approach. Okay, that's why the time complexity, so the space complexity will be always order of n. So whenever you will implement a recursive approach, the space complexity will be always order of n. Okay, so the space complexity will be order of n, and for quicksort algorithm, the time complexity is n log n. So let's take an array and let's see how quicksort algorithm works. And please keep some patience and stay with me. When this video will end, you will understand what quicksort algorithm is, and I will try to make it as much as simple as possible. So let's take some random values. Okay, so we have taken a random array that is not at all sorted. So we will sort it using quicksort algorithm. So in quicksort algorithm, there is a term called pivot element. So now you guys will think, what the hell is this pivot element? So don't worry about this term. It is a fancy term given by the inventor or the developer who have invented this quicksort algorithm. Okay, so it is nothing but when we apply quicksort algorithm, it takes a random value always from the array to start the implementation of sorting. So what we will do, we'll always take first or last element as a pivot element. So now I'm taking the first element as a pivot element. Okay, cool. So yeah, so how it works. So let's at first take three empty arrays. One is left array. So I'm just writing as L. Okay, and empty equal array. So this is left, this is equal, and a right empty array. Okay, so what we will do, we will take all the elements that's a lesser than the pivot elements in the left array, and all the elements that's equal to the value of pivot element that will take in the empty array, sorry, in the equal array, my bad. So all the elements that's equal to the pivot element that will take in the equal array. What is equal array? This name of this array is equal. I mean, the variable name of this array is equal. That's what. Okay, not it's something like equal array. Okay, and in the right array, we will take all the elements that are greater than this pivot element. Okay, so now we will think, if you went through any other videos, you may watch that they generally take two arrays, left and right. Okay, I'm taking this. There is a reason. So if you want to keep track of the order of equal elements, in that case, you should take this equal array. What the hell I'm talking about? So suppose if you have a array like this 7, 5, 7, right? So if you, when you will sort, it will become 5, 7, sorry. uh, so when you will sort, so it will become 5, 7, 7. So now, if you want that this 7 always come first of this 7, so if you want to keep this feature, okay, then you should take this equal array. So this array will make sure that if we have duplicate elements in our array, so their order should not be changed when we will get our output. So now let's get started. So we are taking our pivot element as this 7, right? So 7 is equals to 7. So that means it will come to our under the equal array, right? So it will get pushed into this equal array. Now 88, it is greater than this pivot element, so it will come here, right? It will come here. And now 5 is lesser than the pivot element, so that will come here. 0 is lesser than the pivot element, so that will come here. 2 is lesser than the pivot element, that will come here. 4 is lesser than the pivot element, so that will come here. 9 will be greater than the pivot element, so that will come here. 3 will be lesser than the pivot element, so that will come here. So now if you see, so 5, 0, 2, 4, 3, all are the elements are lesser than the pivot element, so that's are under the left element, left array, and under the right array, all are the elements that are greater than the pivot elements, that's are under right array. So 88, 9. And under the equal array, we have only 7 because there are only one elements that's are equal values of, right? So that's why it's a 7. Okay. So now if you see, so 50243, it is not at all sorted. So I have mentioned a term, right? That is recursive approach. So now you will see what the hell is this recursive approach this quicksort algorithm follows. So if you see, the left portion array has 50243 and that is not at all sorted. So what it will do, it will again implement a quicksort algorithm that we have implemented just now, taking a pivot and left and right. So that will so it will implement the same thing for this array again. Okay, so we have 50243, right? So let's take a new page or new board and we'll see. So what we have 50243. We have 50243. So in the left portion we have this array, right? So so now, as I have mentioned, it will follow a recursive approach. So it will take this 5 as again a pivot element, and it will make left equal and right empty arrays. Okay, and it will do this same approach again. So now pivot element is 5, so this 5 is equal to this 5, so this will come here. 0 is less than the 5, so this will come here. Why? In the left array, again I am mentioning, we will take the elements that are lesser than the pivot element. So that's why 0 is lesser than the 5, that's why 5 is here. So 2 will come here, 4 will come here, 3 will come here. So there are no elements that are greater than the 5, so that's why right element is empty. So now you will see 0, 2, 4, 3. So it will again, this portion will be implemented a quicksort again. So you will ask then why this is not calling a quicksort algorithm again, because this array will contain all the equal values, right? So it is already sorted, that's why, and right array is empty, so that's why we don't have to do anything about that. So now we have 0, 2, 4, 3, right? So if we take another board, so we have now 0, 2, 4, 3, right? So we will take the pivot element as 0 now, and again we will take left empty array, equal empty array, and right empty array. Okay, right empty array. Cool. So 0, so 0 is equal to 0, so this will come under 0, so it will come into equal empty array. It will get pushed into equal empty array. So 2 is greater than the 0, so it will come here. 4 is again greater than this, so it will come here. 3 will greater than this, so that will come here. So now this 2, 4, 3 will again, we apply a quicksort algorithm here. So now 2, 4, and 3. So if we take 2 as a pivot element here, so all the elements that are lesser than the 2, that will come here, but we don't have anything lesser than the 2 here, so it will become empty. And under equal, we will have, under equal empty array, we'll have 2 only, and under right portion we'll have 4, 3, right? So we'll have 4, 3. So now this 4, 3 we have, please go with me, you will understand. And so now we have 4, 3, right? So 4, 3. Don't worry, I will explain again this part. If you don't understand, don't worry, don't leave this video. If you go to another video, you have to start from the scratch, you will understand, trust me. So now we have 4, 3. So we always take the first elements, pivot elements. So pivot element is 4. So now again we take left, equal, and right. Let's take our new board. So what we have? 4, 3, right? So left, equal, and right. So pivot element will take 4. So all the elements that are greater than the pivot element. There is no elements that are greater than 4. That's why it will be empty. And equal array will come 4. And under the, sorry, there is one element that's lesser than the pivot element, that is 3. So it will come 3. And under the right element, it will become empty. So now if you see, so left array has a single element tray. So if array has a single element, so that is already sorted. So there is no need to sort it again. So now if we merge, so right array is empty, so there is no need to merge it. So it will become 3, 4, right? It will become 3, 4. Now if we come here, so we had 2, 4, 3. So this 4 and 3 got sorted, right? This 4 and 3 got sorted. So now it will become, and left array is empty, and equal has 0. So at first left comes, so left is empty, so there will nothing come. So we'll keep this 0 here and this right portion. So 0, 2, 4 and 3 become sorted, so it becomes 3, 4, right? So it got become 3, 4, na? 3, 4. So what we will write? We'll write here 0, 0, 2, 3, 4. Okay, it becomes 0, 2, 3, 4. So now if we come here, so we had 0, 2, 4, 3. So now it becomes 0, 2, 3, 4. Now again we will merge this array. So in the left, at first left portion will come. So at the left 0, 2, 3, 4, and in the equal, so we'll keep the equal part in the middle, because index of this equal element will never change, because respect of the pivot element, we take the lesser element from the pivot element in the left and the greater at the right. That's why it will be always in the middle, right? And right array is empty, so there will be nothing. So 0, 2, 3, 4, 5. So now if we come here, so this portion becomes 0, 2, 3, 4, and 5. And now we have 88, 9. So again we will take a pivot element 88. So we did a recursive approach for the left part, right? So left part is sorted. So now it will go for the, this right array. So we have 88, 9. So we take the first element as our pivot element. So that's why in our pivot element we will store 88, and we have left array, equal array, and right array. So 88 is equal to 88, so it will come under equal, and 9 is less than 88, so that's why 9 will come here. Why? Because all the elements that are lesser than the pivot elements that comes under left array, and all the greater than the pivot elements come on the right and equal at there. So now if we merge it, so in the left portion we have 9, in the equal we have 88, and right array is empty, so it will become 9, 88. Now if we merge this, so finally we got 9, 88. Right now if we merge these three array, so at first left array will come, so that is 5, 0, 2, 4, 3, and then we got 7. So ultimately the results if I write, so we have now 0, 2, 3, 4, 5. So 0, 2, 3, 4, 5, 5. This is the left array, and then in the middle we put this, and then the right array. So 9, 88. Okay, got it? Cool. Now we will go for the implementation part in our VS Code, and you will get a better understanding now. So now we will write a function quicksort, and we'll pass pass an argument array. So I have mentioned, right, that it will follow a recursive approach. So if it follows a recursive approach, it should have a base condition when this function should be stopped. So I'm giving a base condition, if array dot length is equals to 1, in that case we'll turn this function, I mean turn this value array, and we'll stop this function. Why I'm giving this condition? So less equals to 1 means if array length is 0, that means no need to sort this array again, right? So we'll return the empty array. And suppose array dot length is 1, that means if our array has a 1 element, so itself it's sorted, so no need to sort it again, right? So that's why if we go here, if you see at the end it is 3 and it is 4, so no need to sort it again, right? So then we'll stop the array and we'll get our result, right? We'll get our result. So that's why. Okay, so now what I mentioned, that we will have a pivot element, right? And we were taking pivot element as our first element as the pivot element. So array of 0, and right, so pivot element array of 0 7. So now we have taken here pivot element array of 0, and in the left array we were taking all the elements that are greater than the pivot element. So greater than pivot elements, pivot element. Okay, so I will apply filter higher order function. I hope you have a knowledge about filter. What does filter do? It does nothing but it filter out the elements based on our condition. So now if I give a condition here that elements that's a lesser than the pivot element, that should come, that I should get. So what it will do, it will return an array of elements that are greater than this pivot element. Okay, and then we'll have a equal array, right? If you remember, we had here a equal element, equal array. So yeah, that's why I'm taking an equal array here, and again array dot filter this element, and I'm giving a condition element equals to pivot element. Okay, and then in the right array, what we are taking, we're taking all the elements that are greater than the pivot element, right? So that's why I will give a condition all the elements that are greater than the pivot element. So I will get it. So also I'm, yeah, sorry, all the elements that is lesser, sorry, my bad. Okay, lesser than the pivot element that will come in the left, and the greater than pivot elements that will come here. Okay, I wrote I typed wrong. Okay, sorry, my bad. Okay, I hope you understood, right? Sometimes when you explain and write the code, so these silly mistakes happen, so please pardon me. So yeah, but yeah, that's how debugging works, right? So yeah, so in the left element, so in the left array, we are taking all the elements that are lesser than the pivot element. In the equal, we are taking the all pivot elements that are equal value of the pivot element, and right the greater than the pivot element. Okay, cool. So after taking this single array, what we do, we merge, right? After taking, so if you see, after taking when we get the output, we merge, right? We merge. So that's why we'll merge here. So, and one thing, if you see, at first we got 0 2 4 3, right? So it is not at all sorted. So so it divides and conquer till the last element, till the array didn't get sort. So that's why we again call the quick, so again we apply quick sort for this left array, right? So that's why what we will do, we'll call this quick sort function, and inside that we will pass the left array. And now some of you may have doubts that what is this? So this is doing nothing. So suppose if you have an array, just I'm giving an example. Suppose if you have an array like temp and 4 5 comma 6, okay, And suppose now if you take an array and inside that if you do this, okay, it's just a ES6 syntax. So if you do this, it makes a shallow cookie. So what it does internally, it puts the elements in the array and it makes like this. So that's what it is doing. Okay. So yeah, so when we take the left element, so if it's greater than, so it's left array's element, I mean left array elements length, sorry, if the length of the left array is greater than 1, so then it will occur, because so it will again implement a quick sort. And yeah, for the middle, we no need to call the I mean for the equal array, no need to call the quick sort again. Why? Because it is already sorted, right? I mean, if it's holding all the elements that are equal, why need to sort it again, right? There is no meaning of doing that. So again, for the right portion, we will do the same. Why we are doing again here, we are calling the quick sort and doing this, because if you see here, okay, yeah, if you see here, we are getting at the first time 88,9. That's not at all sorted, right? So that's why we will implement a quick sort again, right, till its last element until it didn't get sort. Okay, that's why we are calling the quick sort here again. So now let's take a test array as a test case. So let's take this 788502493 788 5024 cool, 493 493. Okay, so 788502493. So now let's call this function quick sort, and I will pass this test array and let's see if it works. So let's run this file, and whoa, it's working. So 023457988. Now let's put some equal value. So now let's take 2 again here. Let's see if it works. So yeah, it's working. So as I've mentioned that you can take the last element also. So instead of 0, if I do array dot length -1, and if I run this function again, we'll see it works, right? The space complexity will be always, order of ny, because it is a recursive function. And besides that, we are taking some stress spaces also. But yeah, remember that simply that space complexity will be order of n, and time complexity of this algorithm is n log n. Okay. Now you might say that you might ask that between order of n and n log n, which performs better? So if you take short inputs, in that case order of n will perform better, but if you take large inputs in the long term, so at that case n log n will perform better, because the execution time will not make any difference if you take larger values in terms of n log n time complexity. Okay, so yeah, so now if you want to, so the guys who have understood all the parts, so they can leave this video now, and if you are interested to have a one more dry run, so then you can stay, because I'm going to do a one more dry run for the guys who did not understand at all. Okay, so what it is doing, so now we will go again step by step what this code doing. Okay, so let's take a array 5 4 3 2 and 1, and we will sort it. So what we are doing, So let's make it 0 itself. Okay. So we are taking a pivot element first. Okay. So what is the pivot element here? 5. Okay. And then we are taking left, equal, and right. Okay. So left, equal, and right. So okay, if you want to check the base condition also. So what is the base condition? If array dot length is less equals to 1. So this is array dot array length is greater than 1, right? So it will not stop. It will implement the quicksort algorithm. Okay. So now what we are doing, if the elements are lesser than the pivot element, we are pushing into left element. If it's equal, then in the equal array element, and if it's greater than the pivot element, then in the right array element. Okay. So 5, so it will come here. 4, it is lesser than the pivot element, so it will come here. 3, it will come here. Why? Because it is lesser than the pivot element. 2, it will come here. Why? Because it is lesser than the pivot element. 1, why? It is because it is lesser than the pivot element. Okay. So there are no elements that are greater than the pivot element. That's why right array is empty. Okay. Now, if you see, the length of this array is greater than 1, right? So what will happen? So we will call a quicksort again. So now if you see, basically we got left, equal, and right, right? So that's why we are calling a quicksort again here for individually. Because if you see, if we leave this array itself again like that, it is not at all sorted, right? We will get a wrong output. So that's why we are recursively calling this quicksort function again. That's why we're calling this recursively, this quicksort function again. So now, so for 4, 3, 2, 1, let's take a new board. So 4, 3, 2, 1. So now let's take a pivot element. We always take the first element as the pivot element. So p equals to 4. So now let's take left, equal, and right. So in the left, we have nothing. We now we have nothing because 4 is equals to 4. That will come here. 3, this is lesser than the pivot element. So that's why it will come here. 2 again lesser than the pivot element. So that's why it will come here. 1 again lesser than the pivot element. That's why 3, 2, 1. So now right array has nothing. So that's why what we will do, we'll again apply another recursive function. So again this moment has come. So the guys who don't understand recursion, they might have a little bit problem. Okay, please read about recursion, you will understand more. So yeah, so again we'll call our quicksort function for this array. So why we are not calling the quicksort for this equal array? Because equal array will have all the elements are equal, so that is already sorted, right? There is no need of calling this quicksort again. So we are doing 3, 2, 1. Okay, so again let's take a new page. So we have 3, 2, 1. So pivot element will be 3. Let's take left, equal, and right. Again right will be empty because there are no elements that are greater than 3. So in the left it will come 2 and 1, and in the equal it will 3. So again we have 2, 1. So if we call it again, so we will take 2 as a pivot element, and 1 will be the left element, and in the equal array we will get 2, right? Equal array will get 2, and in the left array we will get 1, and in the right array we'll get empty. Why? So we have 2, 1. So if we take the first element as 2 as the pivot element, if we take the first element as the pivot element, so if we go through, so 2 equals to 2, in the equal array we'll get 2, and 1 is lesser than the pivot element, so that's why it will come here, and right array is empty. So now if we merge this array, what we will get? So it can't get more sorted because now we have single elements in each of the array. So now if we merge, so at first what will come? At first left, then equal, then right. So left is 1 and equal have 2, and right array is empty, so here it will come nothing. So 1 and 2, right? So now, so this has become what? 1 and 2. And now if we merge here again, so right array is empty, so left will come first, then equal, then 3, that means that 3, and right array has nothing, so 1 2 3. So now we'll come here, so 3 to 1 becomes 1 2 3. So now again right array is empty, so we write the left array first. So 1 2 3, and this equal array 4, and right array is nothing, so 1 2 3 4. Got it? So now if we come here, so this 4 3 2 1 becomes as now 1 2 3 and 4, and now right array is empty and equal has 5. So we merge this, so we'll write the left array first, 1 2 3 4 and 5, and this right array is nothing. So yeah, that is the sorted form. So yeah, I hope you understood. If you didn't, please revise this lecture. Quicksort algorithm is a very easiest algorithm. Okay, but yeah, for the beginner, if you face any difficulties at first, it is not abnormal. Okay, I also, when I have learned first time, I face difficulties. So this is using extra spaces. This has another approach using 2 pointers, so that I will teach later. So at first digest this fast, and yeah, so that's all from my side for today. Thank you for your time. Bye.